Hey everyone, and welcome to The Explainer. I am so thrilled to have you here today. We are going to unlock one of the absolute most powerful concepts in modern software development, and that is building rock-solid, reliable PHP Symfony applications. If you've ever felt a little overwhelmed by the whole concept of automated testing, or maybe you just aren't sure where to start, you are exactly in the right place. We're going to completely demystify the testing pyramid in Symfony, scaling all the way from the smallest isolated unit tests right up to advanced full-scale application tests. Let's get right to it.
Okay, let's dive into this. How do you guarantee that the code you just wrote actually works? And I mean, not just today, but tomorrow and the next day, especially after someone else on your team modifies it. Development is kind of like this ongoing battle against software entropy, right? You've got those relentless, creeping bugs that just seem to appear out of thin air. We have all been there. The ultimate solution to mitigate that chaos isn't just coding harder or staring at your screen for hours on end. It's implementing structured, automated testing. It is literally the ultimate safety net.
Here is our roadmap for today. First, the quest for reliability. Second, unit testing and isolation. Third, integration and application testing. Fourth, simulating the browser. And finally, mocking and database isolation.
Section 1. The quest for reliability, why we test our code.
Look, it's an undeniable fact that writing tests takes time upfront. But skipping them, that costs far more time in the long run. Drawing from an excellent engineer's blog post, the benefits are just massive. We're talking about early bug detection right in the development cycle, which, let's be honest, is infinitely cheaper and less stressful than fixing a production bug on a Friday afternoon. You get code isolation, debugging becomes an absolute breeze, and you gain total confidence when you're refactoring. Plus, tests actually force you to write your code in a standardized format. They act as this living developer documentation and create faster feedback loops, practically guaranteeing that an application actually does what it's supposed to do. Section 2. Unit testing in isolation. Fixing the micro. So before we can confidently test an entire system, we have to validate its smallest foundational parts. According to the engineer's definition, unit testing focuses on verifying the correctness of individual units of code. This is usually right down at the method or function level, and it's done in total isolation. By using tools like PHPUnit, you might test something as specific as a simple cart service class. You do this by mocking its dependencies, ensuring that your isolated unit calculates exactly what it should, totally independent of the database or any external APIs.
And this brilliantly illustrates the massive contrast between the two ends of the testing spectrum. On the left, you've got unit tests. They are lightning fast and rely heavily on mocks to check just a single isolated method. On the right side, you have application tests. These examine the system as a whole. They actually simulate real user interactions, testing the integration of your routing, your controllers, and your templates. It's absolutely crucial to understand exactly when to use which approach. If you're newer to this concept, just keep this analogy in mind. Think of unit testing as checking a single gear in an engine. You're making absolutely sure the gear's teeth aren't broken and that it spins correctly. But application testing, which is often called functional testing, well, that's driving the entire car. It ensures that when you physically turn the steering wheel, the tires actually pivot. Both are completely necessary, but they serve entirely different purposes.
Moving on to Section 3, integration and application testing, driving the whole car. Now, this is where Symfony's powerful testing tools really begin to shine. Before we jump all the way to full user simulation, we have integration tests. These test a combination of classes and very commonly interact with Symfony's service container. To make this happen seamlessly, Symfony provides the kernel test case class. What this does is it boots the application kernel specifically for the test environment. It makes sure your tests run independently, but still have access to the exact services they need to function together. Now, what's really interesting about this slide is how Symfony manages these isolated testing environments. When your tests boot, Symfony reads specific environment files to configure itself. It starts with .env for your application defaults, then moves to .env.test for test-specific overrides, and finally checks .env.test.local for machine-specific settings. But here is a massive warning. The standard .env.local file is totally ignored in the test environment. This is a brilliant design choice by Symfony to ensure absolute consistency across your test setups, regardless of what weird local development variables you might be using on your own machine. Section 4. Simulating the browser. Real-world user scenarios. To test real-world scenarios, we use application tests. Again, you'll often hear these referred to as functional tests.
To execute these, Symfony gives us a really cool special object called Web Test Case. This creates a test client that acts exactly like a virtual user clicking through your site. As the Symfony documentation highlights, it's a very repeatable, logical workflow. Step 1, you make a request with the test client. Step 2, you interact with the page, like clicking a link or submitting a form. Step 3, you test the response to make sure the application behaved correctly. And then you just rinse and repeat. The beauty here is that this test client acts just like a browser, but without the massive slowdown of real HTTP transport, so it's incredibly efficient. Let's look at how easy this actually is in the code. You use the client to navigate, typing client request for a specific route or client submit form. Then you get to use Symfony's powerful built-in assertions. With assert response is successful, you can instantly validate if a login form redirects properly without throwing an error code. With assert selector text contains, you can verify if an H1 tag on the newly loaded page contains the exact welcome text you expect. It's almost like magic. It gives you complete programmatic control over a virtual user.
Finally, Section 5, Mocking and Database Isolation, Advanced Problem Solving.
Up to this point, things are pretty straightforward, but we need to tackle features that don't rely on simple user inputs. Take a look at this fantastic real-world scenario brought up in a dev community post. Let's say you have a decoupled REST API. It catches exceptions and returns nicely formatted JSON error responses. But what if an exception is thrown by an internal private auto-wired service? Say a misconfiguration or a missing environment variable. You can't exactly just craft a bad HTTP request from the client to trigger those specific internal errors. So how on earth do you test that your application's catch block actually works?
Well, the answer is mocking. A mock object is essentially an alternative implementation of a class where the real methods are replaced with canned data or predefined behaviors to simulate a specific scenario. In this case, we have to inject a fake service into Symfony's service container to literally force the controller's catch block to execute during our test. We are effectively tricking the application into throwing the exact error we want to test. So the crucial point is how we actually implement this cleanly in Symfony. Let's walk through this precise dev community solution. Step 1, you absolutely must declare the service as public in your services_test.yaml file. Why? Because services are private by default in Symfony. If you skip this, you'll get a container exception when you try to manipulate it. Step 2, you boot the kernel and create your client. Step 3, you create your mock of the service. Step 4, you replace the default definition in the container using container set. And finally, step 5, you run the client request. Now your controller will hit the mock, throw the required exception, and you can comfortably test your JSON error response. Now, let's see how this same philosophy applies to database management. When your functional tests modify a database, like creating a new user or deleting a record, you risk massive cascading failures if that data isn't reset perfectly for the next test. To prevent this nightmare, you absolutely must isolate your tests. You can do this by using the Dama Doctrine test bundle, which is recommended in the Symfony docs, or annotations like DB isolation per test seen in the Oral Commerce documentation. These ingenious tools use doctrine transactions to automatically roll back any database changes the moment a test finishes. Your testing database stays perfectly clean every single time. So, we have covered the pyramid today, from unit testing the smallest gears to driving the functional car, all the way to mocking complex internal services and isolating your databases. But I want to leave you with this final provocative thought. Take a hard look at your own codebase right now. Are your tests truly covering your code, intentionally validating its specific behavior, or are they just passing by coincidence? I highly encourage you to apply this structured testing pyramid to your next project to build truly reliable applications. Thank you so much for exploring this with me today. Keep learning and keep building.